Hello everyone and welcome back to the 3D Tinkerer channel. So before we start the video today, I'd like to say thank you to all the new subscribers I have. We recently hit the 400 mark, so that's pretty cool. And today we're going to be talking about soft body physics in Blender and how they work. So on the screen you can see a little demo that I made. It's just a couple of spheres that I drop into a plastic or glass box. And you can see they have that bouncy soft body physics feel. So it looks really cool. This is something you might see in those satisfying compilations on YouTube, where there's a lot of computer generated graphics and whatnot. They aren't always, 100% CG, but anyways, here's just one example that I'm going to be quickly showing you how to build today. But we are going to be going over all of the important settings, or at least the settings that I consider important. And there's also different methods you can use with soft body physics. It doesn't have to just be for sphere objects. Here's a quick little flag demo that I made. It isn't perfect, and the texture could be a lot better, but it shows you just a general feel of how you could make a flag in Blender. And I'm also going to be going over the settings and how you'd set something up like that. So without further ado, let's just kind of jump right into it. So let's just get a brand new scene in Blender. We're going to be deleting everything again anyways, but just kind of pick up where everyone else would be. So here's our basic scene, and what I'm going to do is I'm going to start by deleting everything by hitting A and then X and delete. So now we have a clear scene, and what I'm going to do is, what you could do is hit Shift A and drop in a UV sphere, but the geometry on the UV sphere in my eyes isn't very clean. So what I like to do is I like to make a cube and then head over to the modifiers panel over here. I'm using the latest version of 2.8, so it might be a little bit different from yours. So you might want to pick up the latest version on blender.org. You can see that some of these buttons over here now have color to them. But anyways, we're going to add the Subdivision Surface modifier, and you can see we have a sphere-like object, and we're going to bump up the views to 2, and then we're going to click Apply. So you see we still have a pretty low poly sphere object, but we want to keep it pretty low poly because we can apply a subsurf after we do the physics calculations. But if we have a bunch of geometry while baking the physics geometry or the physics cache, it'll take a lot longer. So we're going to keep it really basic, and I recommend you do this for any baking that you have unless it's something very specific. And we're also going to scale this ball up a little bit, so we're going to tab into edit mode, just scale it up a little bit. And I'm going to hit Shift A, and we're just going to add in a standard plane. And I'm going to hit G and Z, drag it down, and then hit tab to tab into edit mode, and then hit S and just scale it up so we have a little platform. And let's just kind of drag this sphere up. So you can kind of see our scene's already taking place, but now we need to actually tell Blender what is what's going to be our soft body ball and what's going to be our platform. So it's actually really easy. So with the ball selected, we're going to come over to the, which one is it? The physics tab. And all we're going to do is we're going to add a soft body. We're going to enable soft body physics for this sphere. Make sure only the sphere is selected. And what we also want to do is we also want to tell Blender that this plane down here is a collision object, because you'll see if we just run our simulation, the sphere will actually pass through, and we don't want that. So we're going to also click on our plane and just add a collision object, and you could really just leave all these settings as default. If you do want to change something like friction, yeah, you can just go through and actually change the settings yourself. Most of them are pretty self-explanatory, but you do want to make sure if you're changing the friction for soft body, you do it under the soft body and cloth tab instead of the particle tab. You can see right here, friction. We're going to leave that at the default value that it was. By the way, if you ever change a value and want to set it back to the default, you should be able to just right-click it and then reset to default value. Sometimes it doesn't work though. It changes it to 0. So I'm just going to leave it at 5. So again, we have a default soft body and a default plane. Now you notice if we just hit play, our sphere won't actually drop, and that's because when I did the example of it passing through the plane, I actually disabled one of the default settings. And that is, you want to disable goals if you want your object to fall. And basically, goal will let you either lock the object in a certain area or allow you to lock it to certain vertices. So one example of goal that I like to use is the flag. So here's my Blender file for the flag. Now you'll notice that when the animation runs, this side over here stays still, like it's attached to an invisible pole, but that is actually the vertices that we have selected for our goal. So you notice if I go back to the beginning of the animation, I'm going to tab into edit mode, it'll make it nice and flat. So I'm going to go over to the Object Data tab, and you see I have a vertex group called flag. So with it selected, if I hit select, it'll select all the objects or all the vertices in this vertex group, and you'll notice it's the ones on the left here. So let's say that I wanted to, let's say I didn't have a group for it, so we're going to just remove the flag group. So I'm going to do this from scratch. So what I'm going to do is I'm going to select this side row by alt-clicking it in the edge select mode. I'm going to add a vertex group, and then I'm going to hit assign, and now you'll notice if I deselect and hit select, only that edge is selected. So if we go back to the physics tab, under goals you'll notice there's one called vertex group, and if I set that to the group that we made, that'll lock in the physics for it. And the only reason it's grayed out here is because this is I already baked the simulation here. So just to reiterate, if you want your object to fall, turn off goals. If you want it to stay in a place, you can either leave it checked, or you can select certain vertices that you want to be locked. And also with the flag, to make sure that it doesn't droop at all, because if you just set it to the default goal settings and pick the vertex group on the side, it would still droop a bit. You want to make sure you set the strengths tab under goal. So you see here's goals, go to strengths, you want to set the default to 1, and that way the vertices that you selected will never move, in the case of the flagpole. Okay. Anyways, moving past goals, we're going to leave that off for our ball dropping simulation. Now that with it off, you can see that it just passes through. Oh no, it doesn't pass through, but it falls and then hits the plane. But you notice it kind of turns into a small fractal, so we're also going to fix that in a second. So moving on to edges. Now edges is where you're going to spend most of the time with your soft body objects. And honestly, most of the soft body physics is really like trial and error. I literally spent multiple hours just tweaking values, seeing what worked and what didn't. And the main thing that I could say is a huge like factor in this is the bending value right here. This will affect most of your objects, like actual soft body physics. You can actually, there's different settings here, obviously, like pull, push, damp, plastic, and bending, length. But length always seems to be a bit fidgety, doesn't really work the way I want it to. And damp, supposedly, I'll go to the Blender docs right here. And if we go down to damping for edges, it claims the friction for the edge springs, basically it will calm down the cloth with the push and pull effects, but I tweaked the value as much as I wanted and it didn't really do anything. I set it to its max and mins, etc. And I also experimented with pull and push, so I have some clips here. So starting with pull, I set up 4 different spheres, I believe. So here's the pull testing. Now you'll notice that with pull, I set the values to 99 on the end here, 60, or 0.999, 0.6, 0.3, and then 0. And you'll notice with pull, basically it allows the vertices to stretch apart. So when it's set to 0, the vertices can stretch all the way out, and they make this weird pancake design on the end. But on the far end over here, with it set to 0.99, they don't really have much room to like stretch. So it just kind of becomes like a really firm ball. And you can see with 0.3, you get kind of like that desired droopy effect. But you'll notice that now if I switch over to the push setting, so here's the push value, and you can see it's locked at 0.999 or 0. Set it back to 0.5 for now. And you'll see with our push testing here, it actually doesn't really look that different. The only difference you'll see is with the 0 set for push, where instead of spreading out, it actually just kind of turns into a pancake, and that's because it isn't letting the vertices move at all, really. But instead of like expanding, they can't expand, if that kind of makes sense. Again, most of the documentation is kind of vague, But you see here, like I said, with our 0.6 and 0.3 for push, it looks very similar to pull. It's just a kind of different wording of the property. And then if we go to bending, so this is that bending value that I said was pretty important. You'll notice that this kind of just does the best of both worlds in one setting. So the way I have it set up, so bending can go all the way to 10 and all the way down to 0. So in the end here we have 10, then we have 1, and then we have 0.5, and then we have 0. So it's a much more exponential growth with this property sample that I have. But you'll notice that at a 0.5 and 1, it looks pretty good, and all we really did was change one setting. Sometimes the weight of the object also comes into account. So if I drop the object tab here, you can actually change the mass, and by default it's 1 kilogram, which is about 2 pounds. And if you increase or decrease this, it'll be more airy, so it doesn't really collapse in on itself as easily. But you'll notice that sometimes it still might do that. So one thing you can do is enable stiffness and kind of tweak the bending value a bit. Sometimes it seems like stiffness doesn't do anything, and sometimes it does. It's really weird, but mainly you'll get the most results by changing the bending value. So I'm going to leave it at 0. So this is a default soft body, remember. All we did was turned off the goal setting. And let's just review. It drops and it kind of folds in on itself. It kind of props itself up a little bit. But you'll see if we increase the bending all the way to 10 and we hit play again, it just kind of bounces. It's like a perfect bouncy ball. It is a little bit slow for some reason. And you'll see if we drop it down to like 3, let's see what this looks like. It's a little bit more bouncy. Maybe drop it down to 1. You see I'm just kind of like experimenting. So now it's on 0.4. See, it looks a lot more bouncy. So it has a bit of that like wiggle physics. It kind of looks like it's filled with like water or air. So you really have to tweak the settings to get the desired effect that you want. Another important one is self-collision. So the only time self-collision is really important is with examples like the flag. You'll see here I actually have self-collision enabled down here. And the reason you might want it enabled is that sometimes the vertices will actually get really close in the case of the flag, because it isn't like a sphere, it's an actual plane, and with the wind modifying that I'm doing here with a wind tunnel, it's just called wind, I believe, but the tool. But anyways, you'll see that the vertices can actually come down and droop, and they were actually, when I was experimenting, they were actually intersecting each other. So if you turn on self-collision at the bottom, that'll kind of fix it up a bit. And in the case of the flag, you don't really see it with the spheres, but the bending seems to affect the general size of these wrinkles in the flag. So when I had bending set down to 0, the wrinkles were really tiny. It looked kind of like a latex, I guess, or maybe like a paper. That's kind of two very different materials, but basically when I bumped the bending up to about 2.3, I started to get these really big wrinkles. So bending seems to affect that. But at that point, if you're really serious about how the flag looks, you might want to try cloth collision, but we're not going to be talking about this today. So yeah, let's go back to our example. So you can see we have like a nice little bouncy ball here. So you see if I set it down to 0.2 on bending, we get some really like bouncy objects. And just kind of reiterating with the self-collision past the flag example, another thing that I kind of looked into with this is, let's say, so still using the same object. So I'm going to tab into edit mode with our ball, and I'm going to hit Shift D. So we're just copying the vertices and not the actual object. And you'll notice when it's one object, they'll both fall and both have like their individual physics, but without self-collision on, they just kind of clip through each other. So this is one other scenario you might want to do something like this. So here's with self-collision on, you see they actually interact with each other. But I'll show you a different way to do that without having to deal with like this messy one object. So yeah, and also self-collision has some settings like ball size, which is kind of like the sphere of influence, like if you're having clipping problems, stiffness, dampening, all these sorts of things. Usually you can leave the calculation type alone unless, again, you're having clipping issues, but it really depends on your simulation. For the most part, just remember self-collision is obviously self-collision. Solver, that is also pretty self-explanatory. It's kind of tweaking the way it solves the calculations. You see in the description here, it says, it doesn't say it, but basically this is the number of steps per frame that it'll do. So it is a minimum of 10 and a max of 300, but it's usually by default influenced by this error limit, which basically the lower the error limit, I believe the more aggressive it'll be with the stepping sizes. So with this error limit, it'll basically go between the range of 10 and 300 with the quality of the simulation. So say you're having clipping issues, you could always just bump up the minimum to, like, I don't know, 50. It will slow down your simulation, but usually this doesn't really have the same effects as like a rigid body simulation would for more iterations. It's really just dependent on like how fast objects are moving in your scene or how heavy they are. So again, it goes back to that experimenting a lot. Oh, and before I forget, the plastic setting will basically allow a certain number of permanent deformations to your object when it like hits another object or is pushed with like the wind or something like that. So a higher plastic amount, it goes all the way up to 100, will allow for more deformation. And you'll see here this clip that I have. Basically, I have like I believe a plastic value of 20, and you see that once it hits the ground, it pancakes. It doesn't bounce back up. It's a permanent deformation. And I have another example where it hits the ground and it does that pancake. Then an object comes in and presses it, and you'll notice it keeps that deformation. It becomes that plastic material. So if you wanted an object to kind of hold that deformation after it was punched by something, you tweak the plastic value. So those are most of the important settings. So let's quickly talk about how you'd actually want to cache your simulation. Also, speed is under the simulation tab, just in case you wanted to change the speed for some reason. But caching will basically let you hard bake your simulation so that you can it doesn't lag your viewport every time you render it. So you see if I hit play here, it's actually re-rendering at the bottom. So that's what that like. So like the grayed out bit of the simulation is the unbaked and the orange is the baked, but even that isn't permanent. You actually have to actually go to the cache tab here and bake it. And one important thing to note is if you want to like transfer your Blender files from one system to another and it has bake files, it's usually important to save your project. So I'm gonna hit Control S and I'm gonna save this to my soft bodies tutorial folder. I'm just gonna name it tutorial. And you'll notice when we save it, now we have the option to send the bake files to the disk cache. So it's usually best if you check this and turn off library path, because library path will use like something with Blender, like the program Blender, wherever the library path is. So if you set it to disk cache, it'll actually be saved to the file path next to the blend file. And pretty much all you really have to do is click bake and it'll bake your simulation. One thing you might want to do is tweak the start and end time. It is independent of the timeline down here, unlike the water simulations. So for example, if I set the end time to 150, if I hit bake, you'll notice down here our object isn't moving, but it's going a lot faster down there. And if we hit, you'll notice it turns red when it's baked. And if we hit play, we have our ball and it's doing a really cool bounce. And then when it gets to the end, no more animation, but our timeline's still going. So if we wanted to stop it at the end there, we change the end time right here to 150 as well. So our timeline shrinks. So you see there's our ball. And then when it gets to the end of the timeline, it'll just go right back to the beginning like that. So now that we have a very primitive soft body simulation set up, what we can do is apply a subdivision surface. So you'll notice before I apply the subdivision, you'll notice here's our object. If I go to object, shade smooth, it looks very rough and bumpy, as you can see with those sharp edges. But if we apply a subdivision surface modifier, and we're not going to apply it, we're just going to have it non-destructively in our modifier stack. Notice it looks a lot smoother, and you notice that it looks pretty good. It looks really bouncy. It gives that desired effect, depending on what you want out of it. If I go into a side view real quick, the plane's still there. It's just, since we're in the side view, you can't see it. So yeah, it looks pretty cool. So that's how you go about doing that. And with the caching, if you do bake your file, make sure that every time you change a setting and want to see it again, you don't just hit play. You have to delete the bake right here, and then you can rebake it, and it'll bake through the simulation again. So yeah, that's about it for the settings part of this. So I'm going to quickly show you how you would go about making this video over here, the ball render. It kind of has like that nice little Instagram video feel, something you might see in a viral like GIF that gets passed around or something. Okay, so I'm gonna be going pretty fast with this this demo right here because it's pretty basic. If you don't really know what I'm doing, you might want to go to some of my earlier videos where I show you some modeling basics and hotkeys and stuff like that. But essentially, if I hit play here, you'll see we have these objects and they fall on this little cube, and that's about it. We have some lights on the side and a white background. And our camera's here with a square cutout. As you can see, that's going to be the final render. So let's just kind of quickly jump into it. Okay, so we have a new Blender file here, and let's just start doing stuff. So I'm going to hit A to delete everything, or A to select everything, then hit X to delete it. And then what we're going to do is we're going to spawn in a cube, and this is going to be that box that we saw in the demo. So what I'm going to do is I'm going to hit Tab and then hit S to scale it up. Then I'm going to go into face select mode by hitting 3 on my keyboard, and then selecting only the top face, hitting I, scaling it in, and then we're going to hit E to extrude downwards. It'll lock the Z automatically, and I'll hit Z and tab into wireframe so I can see it a bit better. So there's our box. Looks pretty basic. Then what we're going to do is we're going to add in one cube, and then we're going to do that subdivision thing that I was doing. So we're going to add modifier, subdivision, bump it up to 2, and then hit apply. So here's our little ball. Let's scale up this cube in edit mode so there's a bit more room for it to fall. And then we'll just kind of drag it up. So what we're going to do is we're going to click on our cube down here, and we're going to go to the physics tab, and we're going to make this our collision. And then we're going to go to our sphere, and we're going to make this a soft body. So most of the settings I'm going to be using for the soft body have been predetermined from my demo because I did a lot of tinkering. So let's just kind of start from the top. So for the friction, I set the friction to 0.2 because I want it to be a bit more slippery since it looks very reflective in the final render. For the weight, I turned it way down. Let's see here for my demo. It's like, let's just set it to like 0.1. That might be good. It's very low because I wanted like an airy effect to it, make it look like it was filled with air. Simulation, we can leave that at 1. Cache, we'll come back to that later. But for now, what we can do is set it to 1 to 5. So our animation bake will go for 125 frames. We'll also do it in the timelines. 1 to 5. And then we're going to turn off goal because we want our object to fall all the way down. We're going to go to the Edges tab, and this is where it gets a little weird. So I found that pull was fine at 0.5, and then I set push to 0.7. Damp, I left to 0.5 because it doesn't really ever seem to do anything. Plastic, we're going to kind of leave alone. We don't really want it to permanently deform. Bending, we're going to set this to 0.1, and this should give us that not collapsing into a fractal effect, but kind of like a soft body physics that we want. We'll leave aerodynamics the same because we don't need to change it. Stiffness can stay the same, and I believe everything else can actually stay the same. It's very basic. We don't need to do anything with the solver or anything like that. So let's take a look. So if we tap into wireframe and hit play, here's our ball, and you can see there it goes. It gives us a nice bouncy effect. We could always tweak it a bit if we wanted to, but I kind of like where it rests. I guess we could take the bending down to, I don't know, 0.07, a little bit less than what it was. Yeah, so it looks a little bit more bouncy. And then I'm going to go back to the beginning of our timeline to reset the animation. And then what you can actually do, it's very easy. So we're going to hit 1 on the numpad to go into a side view. All you have to do is shift D this object, and when you bake it you can pick any of the objects to bake it, and it'll bake the physics for all the spheres. So I'm just going to put in a couple of them right here with shift D. And you could hit play and it'll do that, but let's do a permanent bake. So I'm going to select the bottom, or we'll select the top one for easy access. And I'm just going to click bake. And let's see what it did. It went through all of them. Oh, I forgot one crucial step. So since these are all different objects, we can't turn on self-collision because they're different objects. But you'll notice they still clipped through each other. So what we have to do is we have to actually tell Blender that they're also collision objects. So they're both soft body, and you'll notice I'll start with the bottom one. We're going to click collision. And if I did this in the first place, I could just shift D them again, but I'm just going to manually add them to each one. And in these objects, or in this collision panel that pops up, you could change the friction and whatnot, but it's fine as default. So let's try that bake one more time. So I'll collapse this collision tab, go back to soft body, we'll reset the bake, and now we'll bake it again. You'll notice it's taking a lot more time this time. Let's see what that looks like. So we'll hit play, and you can see they all just kind of bounce onto each other. You'll notice they're a little bit too perfect in like the alignment. So what I did was, let's go back to the beginning. I just kind of varied them a bit. So if we hit 3 on the numpad, I just kind of moved them along the y-axis a little bit, kind of make some like pseudo randomness like that, or pseudo randomness, I believe. And again, of course, we have to rebake them because we moved our objects. So delete bake and then bake again. Then we'll hit the play button, and there's that bouncy effect. So let's get a solid view from the top. Actually, let's hide our object. Since they're baked, we can hide that cube and it'll show us. So you can see they look pretty bouncy. Now, and again, I could have did this when they were all one object, but we're also going to add that subdivision surface modifier. So I'm just kind of giving myself extra work by doing this after I duplicated, instead of waiting till the end. So now they have more geometry, but they're still using that underlying basic geometry for the bake. And again, we have to select these objects and go to Object, Shade Smooth, and now they all look super smooth. So if we hit play, you'll notice they look super bouncy and they still look really smooth. So that's pretty cool. Now that all we have to do is add in some materials and that basic floor. So I'm going to add in a plane, hit GZ to bring it down on the Z-axis, and then we'll tab into edit mode, scale it up, make sure it's kind of clipping the bottom of our cube so it looks like it's on the ground. And then all I did was I tabbed into edit mode, hit 2 to select the edges, and then shift click both of these 2 edges over here, hit E, Z, extrude it up, and it looks a little blocky, so I added a subdivision surface, and it looks too smooth now, so tab into edit mode, Control R, and we'll add in some edge loops to wrangle in that subdivision surface. And we'll bump it up a little bit so it still looks smooth, and then we'll go Object, Shade Smooth, and it looks like a nice background. So let's quickly shade everything. So if we go into the shading tab at the top, let's select our cube right here, we'll hit New, and we don't want principled BDFs. You can have it if you want, but I wanted a clear glass shader. So we'll add that in. The roughness can stay at 0 because we want it to be see-through. Then we'll add a quick one for our background, even though it's going to be white anyways. We're just going to set the roughness to 1 and the color to pure white. And then for our little balls, what I did was I set the base color to either R, G, or B. In this case, let's just do blue. So I set it to blue, and I set the roughness to, I believe, 0. But it will be super reflective, so you should keep that in mind. And I'll just copy it in this case because I don't feel like making a special one. All I did was change the color for the other ones. So it's very basic. So you can see there's our thing, it's coming together. And then what I did was I added some lights. So you can do this if you want. I hit Shift A, added in a light, and I chose area lights. And then let's just move it over here, bring it up, and then rotate it so it's facing our scene, like so. And you'll notice it looks pretty small. So what I did was I went to the light bulb tab over here, which is just the object data for lights, and I bumped up the size quite a bit because I wanted a big light. And you'll notice there's a bit of a weird like sizing issue. So you'll notice it's set to 10 watts, which I guess is the way they do lights now in Blender. But there still isn't any light, and I think that's because of the scene scaling. I don't know if it's new to Blender 2.8, it seems like a bug, but basically if you go to the Scene tab here and go to Units, if you take the scale down quite a bit, let's go back to our light, and if I type in 10, you'll notice it's a lot brighter now. And remember, it was at 10 before, it just scaled down with the scene. So I'm actually, I believe I set this to like 80 or like 200 or something. So you see we have a nice bright area lamp for our scene. And we are using cycles, of course. That's what I used for the balls. So let's Shift D and bring this one over here. So I made 2 of them. And then what I did was I set this other light to be, I believe it was like a light reddish pink, something like that. So you can see that kind of gives us that nice cross section of color. We have the bright light. I did have the other one a bit lower, so I'll set it to 70, just a little bit lower. And let's quickly add in a camera. So I'm going to hit Shift A, camera, hit 0 on the numpad to snap into it, hit N on the keyboard to bring up the side menu, and they moved things around a bit. You'll notice there's a view tab here now, and if I check a lock camera to view, that'll let us move the camera around without snapping out of it. So I had it set somewhere around here. While we're here, let's click on our camera. Or no, we don't want to click on the camera, sorry. We'll go to the Output tab, and if you copy the 1080 pixels right here by hitting Control-C and then hover over the X resolution and hit Control-V, it'll give us that nice cube shape. If you don't want it to be at this pixel count, you can change it, but as long as they're equal, they'll be square. So let's move our camera in a bit more, and then we will uncheck the lock camera to view so we can move out of our camera. And that's pretty much it. You see, if we look through our camera right here, this is what it'll look like. It'll take quite a bit to render if we use cycles. You could do Eevee if you want, but you'll have to change some things about it. One thing that I'll say real quick is that it doesn't seem to be happening now, but I had a lot of weird black artifacts. Let's see if I can kind of move into position. Yeah, it looks like it looks okay. I think if you set shading to smooth, you'll have more problems on the box. But if you do have any like black artifacts on it, what you can do is just go into the Modifiers tab and just add a Subdivision Surface, and then do that. What did I just hit? And then hit the Control R button to make edge loops, and you could just block it out, and that seemed to fix it. But it seems like if you have it on flat shading, you don't have that problem, so you could probably leave it like that. So yeah, that's pretty much it for this tutorial. So I was going pretty fast towards the end, but if you have any questions, feel free to leave them down in the comments. And of course, Blender does have a doc for soft body physics. Again, it's a little bit vague sometimes, but you just kind of have to experiment around with it. It's still pretty cool. So yeah, that's about it for this video. Thanks for watching. If you have any comments or ideas for another video, leave them down below. And please subscribe if you want more content. So thanks for watching, and have a good one.